Good afternoon, good evening, and welcome to those who may be watching our recording today. My name is Stephanie Lewis. I will serve as your moderator today. Thank you so much for joining us for today's National Institute for Congestion Reduction webinar, One Bus Away and its implementation in Mayagüez, Puerto Rico, strategies to transform travel behavior and reduce congestion. So with that, it is my pleasure to introduce our presenter today. So Dr. Valdez, go ahead and take it away.
Thank you very much, Stephanie. My name is Didier Valdez. I'm a professor at the University of Puerto Rico at Mayagüez. I was in charge of this project, so thank you very much to NICER for all the support and for our listeners that are interested in this topic. Well, in this webinar, we will present the implementation of an open source platform called OneBusAway in the city of Mayagüez, Puerto Rico, and discuss the development of several processes aimed at better understanding the system and providing tools to analyze the strategies that will increase the public transportation ridership and reduce congestion. After the introduction and objectives, I will briefly describe the general features of the Mayagüez transit system and the implementation of OneBusAway in the project that involved 3 phases. As a matter of introduction, let me start by saying that in order to provide some context for this project, I want to highlight that innovation in transportation is growing daily. This is how the project aligns with the themes of smart cities, complete streets, and other strategies to enhance mobility in urban areas. OneBusAway aligns with smart cities, complete streets, and aligns with several of the elements in the vision of Federal Highway Administration for the smart and the U.S. Department of Transportation for the Smart City Challenge. Several elements are incorporated in this kind of technology, especially those regarding mobility and connectivity, where the physical and virtual worlds comes together to improve people's activities and society's development. Let's watch a short video promotional that we put together. We put together for this project. Let me see. Just people waiting for the bus is part of our daily routine. But waiting updated bus arrival information. It would be great to have an application that gives you that type of information. As in many cities, we are the National Institute for Congestion Reduction and the University of Puerto Rico has been working on this project for some time. The general objective is to present transit ridership increase strategies and implementation in Mayagüez of the open source platform OneBusAway and all the activities that we developed around it. This project was carried out in 3 phases. The objectives are outlined as follows. In phase 1, well, basically the initial implementation until we launch the beta version of this program. Then the phase 2, enhance initial performance, develop system models, and explore congestion reduction strategies using transit and OneBusAway. And in phase 3, enhance data quality and integrate it into planning processes to develop strategies for reducing congestion. The project was implemented in partnership with the municipality of Mayagüez to deliver real-time information to transit system users. Let's examine some key features of the Mayagüez transit system. This transit system serves both urban and rural routes. There are 3 systems, each with different operators. Sonel, a private company, operates the rural routes under concession, which have fixed schedules as shown in the table, and that was the one that we used for our implementation of OneBusAway. In terms of the methodologies, let's review the methodology for phase 1. This methodology involved familiarizing with OneBusAway and the Mayagüez transit system and forming collaborations with the municipality to deploy the application. The beta version of the app was launched at an event at the Mayagüez municipality facilities, marking the completion of phase 1 of this project. You can find more information about this phase in previous webinar available on the NYSER website. I'm going to be talking today about the phases 2 and 3 in more length. Phase 2 methodology involves refining the app, evaluating its performance, conducting focus groups and a user survey, and developing an econometric model to analyze the data. It also included studying strategies to increase ridership. A focus group was initially conducted to collect information about user experience with OneBusAway in Mayagüez. A second focus group was held to gather information on typical values and ranges that could be used in the survey, as well as to understand key aspects of interest to the system users. Through the focus groups, important feedback was also gathered, such as concerns about safety at stops and users' desire to route extensions to reach areas of high economic activity not yet covered by current routes. A survey was conducted in the area influenced by the rural routes of the rural team. We started and we conducted this survey with that included several sections that gather information about people's trips, characteristics, satisfaction with the operation, their opinion about stops, and demographic details, among other things. Issues to highlight include that some of the answers, having an app with real-time information was important to more than half of the respondents. They also emphasize the need for clearly marked stops with signs. And users of all ages reported using the TIN system, as you can see here in this figure. Even though we have a lot of people using cars and other transportation modes, still there is always a very good group of people using transit in different ages. Actually, 18.7% reported using transit among all the modes available. In terms of obstacles to using transit, it's important to note that some of the obstacles include unfamiliarity with routes and stop locations. This is something that a system like OneBusAway can help to improve. A very important finding is that nearly 50% indicated that they would leave their cars and use transit if they had an app that provided real-time information on bus locations and estimated arrival times at stops of interest. This was a quite surprise for our team, but it just highlights also the importance of the work that we have done. Boarding data supplied by the team system operator SONEL were then used to determine demand at the stops along the routes and to serve as dependent variable in spatial econometric models of trip generation. As shown in the image, the data was recorded manually. The data from the boarding over a full year was digitized, and the results of the boardings by route were obtained. You can see here around 30, almost 34,000 people use one of the routes. That's the largest number here in Route 106. Also, boarding were analyzed during both the morning and the afternoon periods, and the data was analyzed in both directions, from the city center to the outskirts, and from the outskirts back to the city center in these rural routes. Well, at this stage, a spatial regression model was also estimated to connect boardings to zonal variables within a trip generation model along the routes. After obtaining the dependent variable from boardings, the zones of influence were mapped along each route, subdividing them based on the location of stops. The explanatory variables were derived from census data for each zone, particularly from the American Community Survey, ACS. After selecting uncorrelated variables and applying a negative binomial distribution in the spatial regression model, the model was generated and is displayed here on the screen in the table to the right, and it included significant variables such as the motorization rate, people per household, average age of residents in the area, and average household income. Those results were the more significant explanatory variables. Then we also studied strategies to increase ridership, and also in lieu of those strategies, we went a little bit overboard and suggested some actions that were needed in order to try to implement those kind of strategies. These strategies included and are in the literature: demand responsive transit, place making, mobility as a service, transit-oriented development, and real-time transit information, which is the one that we are applying here. Additionally, issues were raised that the municipality should address to build trust among potential users and implement strategies like those mentioned before. These type of issues include establishing a strong system with a user-focused network and excellent service levels, and then incorporating this issue into transportation system improvement planning. Now, after phase 2, we started another phase that was phase 3. In this case, phase 3 was a collaboration with USF. So I have here the methodology for both USF and UPRM, and our activities included collecting ground truth data to enhance data quality and utilizing OneBusAway data in transportation demand modeling, including high-quality data. Initially, a dashboard was created by our research team to display OneBusAway information. The datasets were created considering the architecture that includes multiple programs and databases to identify where the dashboard data would be collected. Then the data was processed and arranged for display on the dashboard. The process of collecting ground truth data was conducted with OneBusAway. For this purpose, specific paths were identified and defined to collect the data. The information was collected, during communication with USF, the data from OneBusAway was requested from the OneBusAway servers, and then we performed the matching process. This is an example of the trips conducted for ground truth data collection, and an example of the information received from USF and that was retrieved from the OVA servers, and an example of the matching process that we conducted here with our research team. However, a more streamlined approach was envisioned. That includes the development of a new mobile app for transit research that we called Travel Transit Tracker. This is an image of a screen that requires login, then allows the user to select a route and enter additional trip details like purpose or mode, and then finally view the real-time information from the bus. One additional feature that this app has is that it not only can include transit trips, but trips made by any mode, and then as long as it's in the area where we have transit service. React Native, Node.js, and Firebase were used alongside OneBusAway as open source programs in order to develop this new app, the Travel Transit Tracker, as we called it. And this is the basic framework for how Travel Transit Tracker operates and interact. And then again, several paths were established, documenting the information collected and obtained through the application. This offers more details on the trips provided by the users themselves, and the system can be used for multiple modes, as I was saying before, resulting in better information for the planning models. Well, finally, the work was completed on the transportation planning models for the municipality. So, for this part, we had to define the transportation zones for the planning model because there is a general planning model for all Puerto Rico, but it was not detailed for what we did was initially to define the transportation zones and centroids using information from the census blocks and also information from the Puerto Rico 2045 planning study. That was a study conducted by the Puerto Rico Highways and Transportation Authority, the planning office. Then data for the trip generation model is presented here in using a QGIS image where you have the centroids, you have the transportation zones, and also the public transport routes. Okay. The data was then analyzed in Transcat to develop the generation model, the trip generation model. And this image displays the results of the generation model using Transcat. The information from the long-range transportation plan was used as initial information for this part of the model. After that, the trip distribution model was developed in Transcat as well, with the results shown in the image on the left, and the transportation network, including all the nodes and links considered in Transcat, was then built for this model, and as displayed in the image from the right. Finally, the trip assignment process was performed in Transcat, resulting in the outcomes shown in these images. On the left, you see the transit routes. On the right, you see the combination of assignment of trips to vehicles and also transit trips. Well, a cyclical process depicted in this image on the right is proposed then to the municipality, yeah, to incorporate crowdsourced data collected through OVA or TTT into the planning cycle. So as part of the information entering into the models, we can use the information collected and received from crowdsourced data and improve the quality of data that we are using to develop these models. This process starts by defining the objectives and the required data. Then we use the mobile apps and the GPS to obtain travel data, and that travel data can be then used for a couple of purposes. One of them might be to enrich the data related to transit, and also to see if the results from the models or from the planning models are reflecting the data that you observe in the apps. Then we analyze the results, refine the strategies, and define objectives, etc., and continue in a cycle of incorporating this information to the planning models. Well, in summary, over the 3 phases of this project, the open source OneBusAway platform was implemented successfully in Mayagüez. A specific application developed for the municipality, which is the TTT, that allows data collection from various transportation modes, was created. Is this new application tailored to the research needs that we have, and also to collect data that can be used in the planning models. Then we also understand better the public transportation system in the municipality. Then we implemented this planning model of the city of Mayagüez in a commercial program in Transcat, and developed a strategy to integrate the data obtained from the application with the planning models to improve the input data by providing more information on public transportation trips, and provided trip data to verify and calibrate the results of the trip allocation model. And finally, we develop examples of strategies that can be used to increase ridership of public transportation systems, and how they can be connected using a tracking system like OneBusAway. Additionally, the challenges and needs that must be addressed to implement the type of strategies that have that we need to implement to increase riderships in Mayagüez or also in other cities were also identified. So with that, I want to thank you very much, and thank you, Stephanie, for the opportunity.
Thank you so much on behalf of the National Institute for Congestion Reduction. Thank you so much for watching today's webinar, and we'll see you all real soon. Bye, everybody.
Bye.